All right, welcome to this video on partial fraction decomposition. As you can see, as it comes crashing down to the ground, we're going to talk about partial fraction decomposition with non-repeated linear factors. And in this video, this is the second video in the series. So if you missed the first video, in that video I covered more of the introduction into partial fractions, the basics of what they are, some of the terminology used in creating partial fractions, and I also went over the basics of the decomposition part. So if you missed that video, please feel free to check out that video. It's video 1. As you can see from the title here, we're going to talk about non-repeated linear factors. And from the example I have here, we're going to wind up, now this is just going to be a quick overview, and then we're going to get into every step in the process, step by step. It's more of a 7-part process. So if we looked at this example here, and just as a quick review of what I talked about in the first video, we have a rational expression, and we're going to break it up into partial fractions. Basically what that means is we're going to break it up into the sum of its parts. The first step that you would do is you would actually take a look at your denominator, and you would factor it. So if we factor the denominator, that's really what we have there. We have x minus 4 in parentheses times x minus 2 in parentheses, and we can see here, what you see is they're both non-repeated linear factors. Now, again, I covered this in that first video. What makes them linear is you want to look inside the parentheses. So if you look inside the parentheses here, the exponent is a 1 and the exponent here is a 1. So inside the parentheses, the exponent is a 1. That makes them linear. And what makes them single or non-repeated is the exponents outside the parentheses. So they're both 1s on the outside. If it was anything other than a 1 on the outside of the parentheses, you can see here and here, that would make them a repeated factor, and that's not what we're covering in this video. That's going to be for subsequent videos. So what we would do is we would take our factor denominator and we would recreate the sum of its parts. We would create a fraction for each factor in the denominator. So we have one factor here in x minus 4, and we have another factor here. So we're going to create fractions for each factor. So we're going to have 2 fractions. So again, we're going to have a fraction for x minus 4, so you can see it, and then we have it right here. And then when we create the fractions, the parts, you always put addition signs in between your fractions. It's just easier to deal with sums rather than subtraction. And we're going to have another fraction here for this other factor, x minus 2. And what you do is, so that covers your denominator. And what you do for your numerator, you can see I have a and b here. And again, I did cover this in that first video. What you do is for your numerator is you start 1 degree less than your denominator. So in the denominator I have a linear. So you have to start 1 degree less, which would be a constant, and you have to account for all the factors from where you start all the way down to the constant term. So for instance, we have a linear factor here, so we have to start with a constant because it's 1 degree less than what you start with, and you have to go all the way down to the constant. So we start with a constant and basically end with a constant. And that's the same thing for this other factor here. This is a linear factor, so again, we have a constant factor, and then that's all we need in the numerator. So the way you start your fractions off in the numerator is you start with a, and you're just going to go down the alphabet for each numerator and each fraction. So I have 2 factors here. So we start with a, and then the next fraction would be, if we had a third factor over here, then the next fraction's numerator would start with c, and you just go down the alphabet. And you don't repeat anything as you go down. You don't repeat any letters as you go down the alphabet. And then what we're going to do is we're actually going to figure out what a and b are. We're going to need numbers to represent those variables, and those numbers are, when we combine the fractions, are going to equal what we have in the numerator here. Again, so we're breaking up what we start with into the sum of its parts. So, if we did that for this one, this is what we'd wind up with. So what I'm going to do now is we're going to walk through the entire process step by step with one of the examples that I have. So let's go to the process. here's the example we're going to work on. We're going to decompose into partial fractions. We're going to do q of x equals x plus 14 over x squared minus 2x minus 8. And then, like I said in the beginning of this, it's going to be more of a 7-part process, seven steps here. So the first thing you want to do, step 1, is you want to factor your denominator, okay? It doesn't really buy you anything to do anything with the numerator if the numerator isn't factored, because we're really recreating the numerator. What you really want to focus in on is your denominator. And if we factor the denominator, this is what we wind up with. All right, these are my factors here. We're going to have x minus 4 times x plus 2. And again, since both of these are linear inside the parentheses, and both of these have exponents of 1, these both would be, we use single or non-repeated. You can use that interchangeably. So these would be non-repeated. All right, these are going to be non-repeated linear factors. And it makes a difference what type of factors you deal with. All right, so these are non-repeated linear factors. It's really important to identify what type of factors you have right away, because that's going to dictate how the rest of your decomposition goes. So that's it for step 1. It's basically just factor the denominator. That's fairly straightforward. Now the next step, we're going to go to step 2. This is where you do the decomposition part. So what we're going to do is we're going to start with basically this part here of the function. We don't need the function notation anymore. We're just going to start with the right side. So we're going to have this. And again, we said that, we have 2 single linear factors. So what we're going to do is we're going to create a fraction, just like I did in the beginning of this. We're going to create a fraction for each linear factor in the denominator. So the first fraction is going to be for x minus 4. So we would have a fraction for x minus 4. And again, it's linear. So that's going to be, that's going to tell us what our numerator is going to be in a minute. And then we always put plus signs in between. And then we're going to have another fraction for x plus 2. And then all we need to figure out is how we start the numerator off. And again, since both of these are linear, we have to start, remember, your numerator, so just make a little note, your numerator is going to start 1 degree less. Okay? Your numerator is going to start 1 degree less, and it's going to account all the way down to the constant term. So we're going to start, since these are both linear, we're going to start with a constant term. So we're going to start out with A, and we're going to go to B. Again, we just go right down the alphabet, and we do not have to, we're not going to repeat any terms. So just for a quick clarification, if this was a quadratic term, if this was like x squared minus 2, for instance, what we would have to do is in this term here, for the numerator, we would have to account for the linear term, because that's 1 degree less. And then we would also have to account for the constant term. So this would actually start out ax plus b. Okay, and then the next fraction would start with c. We're going to get into quadratic factors in future videos. So that's basically how you start it off. All right, you have your denominators are going to be created for each separate factor there. And then your numerator is going to start with a, go to b, and they're both going to be constant. So let's go to the next piece. Now, the next part says multiply both sides of the equation by the denominator of the left side. So what we want to do is we want to get rid of the fractions now. So here's what we had from the previous slide. This is exactly the way we started it. So we filled in, A and B for our numerators, and these were our factors. Now, what I'm going to do is I want to multiply both sides of the equation by the denominator of the left side. That's going to wind up getting rid of the entire fractions. We want to get rid of all the fractions here. That's going to make it a lot easier to work with. So what I'm going to do is I'm going to put brackets around the whole thing. All right, and we're going to wind up multiplying both sides of the equation by the denominator of the left side. So you can see it. We have x minus 4 times x plus 2. and I just included it on both sides of the equal sign. So now all we're going to do is multiply this. So when I distribute this into the parentheses, all right, we're going to wind up, so this is going to wind up canceling, and we're going to have x plus 14. And when I do it to this side, we're going to have to multiply it to this side. So the x minus 4s will cancel. I'm just going to write this out. And we're going to wind up having a times x plus 2. So if I write that out, that's what we're going to have here. And I'm going to have my plus sign. And when I do it to the other fraction, when I multiply this times the other fraction, what's going to happen here is the x plus 2s are going to cancel out, and we're going to wind up having b times x minus 4. So I'm going to write that out. We're going to have b times x minus 4. And, you know, just to clean that up a little bit, you can see what I have there. It's exactly, you know, this is exactly what I have here, just in a little cleaner form. So we have x plus 14 equals a times x plus 2 plus b times x minus 4. All right, now I'm going to take this equation and we're going to continue it with the next step. And in this step, we're going to wind up, you can see what it says. It says expand the right side and group like terms in parentheses. So here's what we started with. All right, this was exactly the way we left it on the previous slide. And all I'm going to do now is I just want to multiply on the right side. So I'm just going to multiply inside the parentheses. I just want to distribute. And again, you know, that's going to leave me, you can see what's going to happen here. I have x plus 14 equals ax plus 2a plus bx minus 4b. So all we did was distributive property. And this is the result of the distributive property. Now the next part of this says you want to group like terms in parentheses. So you just need to group terms with x. Okay? So anything with an x variable, we're going to group together. So we're going to group this one and this one. And then we're going to group constant terms. So all the like x's are going to go together, and anything that's a constant term, now anything without a variable here, anything without a variable x is going to be equivalent to a constant term. So we're also going to group those. So I'm just going to make a little notation around those. So we're going to wind up grouping the 2a, and then we're going to group the negative 4b together. All right, so we're going to group, as you can see it, we're going to group terms with x, so any like x's. So for instance, any x to the first would be grouped together. If I had something in this equation that was x squareds, you would group x squareds. And anything with a constant term, we're going to group those together. And here's what we're going to wind up with. And that's the result of the grouping. And you can kind of see what I have here. So, you know, I have the two x's are going to be here, grouped in parentheses. And then you can see my constant terms over here. So two groupings. And we're going to go to the next slide. So that's just grouping it for the next piece. Now, the next step, it says factor and match to left side of equation. All right, so here's what we had from the groups. That's from the last slide. And when you factor this, all right, you only want to factor terms with an x variable. So basically, if I look at this, I only want to factor parentheses with x. This one here, this parenthesis here, I don't have to factor this. I know I can factor out a 2 there, but anything with a constant, you don't have to factor out with a constant. Okay? So you don't have to, I'm going to make a note here, don't factor your constant terms. And you're going to see why in a little bit. So we're not going to factor our constant terms. Only factors, you're only going to factor anything with an x. You're going to factor out an x. And you can see the little animation there. So we're only going to focus on that first parenthesis. And we're just going to factor out the x here. And again, we're going to leave this one intact, and you'll see what it looks like. And that's exactly what it is. So all we did is from this first parenthesis, we just took out an x, and in the second group, I didn't touch anything there. I left it as is. So no matter what equation you have, you only want to factor parentheses with x, variables of x. Anything that's a constant you can leave. Now the next part is interesting because it says, I'm just going to underline this, it says match to left side of the equation. So what does that mean? Well, if I look at this equation here, I'm going to just put a little coefficient. Let me just change this one bit. The coefficient here is 1, all right? And what I have here is an equal sign, right? So basically everything on the left side has to be equivalent to everything on the right side. So what I have here in front of this x is a 1. Well, on this side, I should also have a 1. But instead of a 1, I have a plus b. So this a plus b is taking the place of this 1. So that's basically telling us that a plus b is equivalent to 1. And that's how I'm going to write it out. I'm going to write it out over here. I'm going to say that a plus b is equal to 1. Because if we have an equation, this side has got to be equivalent to this side. And if I have a coefficient of x on this side, it has to be equal to the coefficient of x on this side. So that means that a plus b has got to equal 1. Now the same holds true for the constant term. I have a 14 on this side, and this is my constant. And remember, this expression here is representing the constant term. Well, if this side of the equation says my constant term has to be 14, then 2a minus 4b has got to be the same as 14, has to be equivalent to 14. So I'm going to write it that way. We're going to say 2a minus 4b has got to equal 14. All right? The left side of the equal sign has got to equal the right. This is basically a placeholder for the number 14. They're equivalent. And you can kind of see what's going to happen here. Basically now I have a system. I have a linear system. So I'm just going to, it's going to do a little animation there, and you're going to see how I equate it. So you can see it. This x is equated to this x, and this 14 is equated to 2a minus 4b, and that's what I have right here. So here's the system that we're left with. We have a plus b equals 1 and 2a minus 4b equals 14. And again, that's basically what I just have written over here. All we did was, and this is an important step here, all you have to do is match up the left side to the right side. And that's why that factoring step was so important. And it's also why I didn't factor the 2 out. You want to make sure your constant terms stay unfactored, because now we have 2a minus 4b equals that constant term. Now we have a little bit more of an easier equation to deal with. Now what we're going to do is the next step is we're just going to solve this system. All right, so we just have a few more steps to go through this. And you can see right here, I've got a plus b equals 1 and 2a minus 4b equals 14. And we're just going to solve this. So I have a choice. We could do, for this system, we could do elimination or substitution. I think I'm just going to do elimination. So I'm going to break that out a little bit. And there's the system. We're just going to work on that. And again, I'm going to do elimination. And I could eliminate either variable. I think what I'm going to do is I'm just going to eliminate a. All right, again, b would work just as fine. So we're just going to eliminate a. So I'm going to multiply the entire top equation by -2. We're just going to distribute the -2 into the parentheses. And that is going to leave me, after I distribute that, we're going to wind up with -2a minus 2b equals -2. And you can see it right there. And then the bottom equation will just be copied over. And then now after I've distributed the -2, I'm able to cancel the a's. So now I can just put my plus sign in my addition bar, and the a's are going to wind up being canceled. And now what I'll have left is, you can clearly see that we're going to combine these b's. So we're going to wind up with -6b equals 12. And then we're just going to solve for b, so I'm going to divide by -6, and we're going to get b equals -2. So there's my first answer, b equals -2. Now all I need to do is figure out what a is, and I'm just going to substitute this -2 into either of my original equations in the system. I think I'm going to use the top one. So if we go to the next part, you can see it just says solve for remaining variable. And after I substitute that -2 in, I'm just substituting that in for b right here, we're just going to solve for a. So I'm just going to add 2 to both sides, and we're going to get a equals 3. So now I have both of my variables, and we're pretty much ready to put everything back together. So there's my 2 answers, A and B. And we're going to go to the next slide, which is basically just the reconstruction of the whole problem, and that's pretty much it. So last step says rewrite as partial fractions. So here was the original problem from way back in step 2, where after we decomposed it. So this is what we were left with, and we had, A and B here. And if you remember from the previous slide, we said A was equal to 3, and B was equal to -2. So all we're going to do is substitute those in, and we'll get our final answer. So here it is in all its glory. And that's the full partial fraction decomposition. So x plus 14 over x minus 4 times x plus 2 is equal to 3 over x minus 4 plus -2 over x plus 2. And that's the whole process. So we basically, deconstructed it, and then at the end you reconstruct it, put it all back, and that's what the partial fractions would look like. So hopefully you enjoyed the video. We're going to, keep going along in this series on partial fractions. We'll have other videos where we do repeated linear factors. Again, we had single linear factors here. We'll do videos with repeated linear factors. We'll do some with quadratic factors, and then maybe some with repeated quadratic factors, and so on. And stay tuned for more in this series. Looking forward to see you in the next one. Take care.